Hi, I'm going to start with the June 13 surds question. Nothing difficult about this in terms of method. You know how to rationalise these sorts of surds, but doing this accurately is quite difficult when there's numbers like this. Many of you may prefer a table to get these answers right. You might want to check whether you've got each part right before finally getting a final answer. On question 5, you need to be able to do a completing square when it starts with a 2x squared or a 3x squared, and you can see the method applied over here where you take out 2 as a common factor. You don't have to take it out of the last number, but you can do so if you want. And again, over here you can see all the answers to that. Remember, the minimum value is the y coordinate. So the vertex will still be minus 3 over 2, comma 1/2. Again, for this part, you're using the formula for Pythagoras for working out the distance between 2 points. That's the meaning of AB squared, the distance between A and B squared. Apply it to these parts carefully. Over here, have a look. Simplify this bracket before expanding it. This was a very difficult question in the mock exam. Not many people understood it. To find the minimum value of AB squared, first the minimum value of the bracket part is 1/2. This was to connect it to the completing square part earlier. And so for AB squared, it'd be 5 times 1/2. So AB will be the square root of that. And then the rest of this, as you can see, is how to change this answer into this answer. This is a fairly standard question for us, but technically difficult. Real roots. Start with the discriminant being greater equal to 0. Identify very carefully what A, B and C are. Have a look at this carefully. B includes the minus sign, so an easier option is to multiply it out so you've got a single bracket for B. As you put the information in, you get to this line of working out. Again, quite a common step here, multiplying by -1, which changes the inequality symbol as well. What makes this question in the second part quite difficult is factorising quite a difficult quadratic. As you can see, you can use any appropriate method, but whether you're factorising or using the quadratic formula, it's going to be difficult getting this right. And there's not a lot you can do with this question if you weren't able to factorise this. Pay attention to the method for solving a quadratic inequality. Identify clearly where it crosses the x-axis. Sketch. Shade the part you're looking for, which is below the x-axis, less than 0. And then your final answer over here, clearly written. Again, a standard question, but one which often students forget. Have a quick look. You're given dy by dx. You need to find the equation of the tangent in the first part. This is fairly simple. Most people got this right in the exam. And then the equation of the curve. That involves integrating the dy by dx formula, which gives a plus c at the end. And then you make use of the coordinate the curve passes through to calculate c by substituting that coordinate into the graph equation. Once you've calculated c, rewrite the equation fully. Another discriminant question, this time involving solving 2 equations together to find a point of intersection. To solve these 2 equations, you put y equals to y, which is this line over here. The rest of it is a rearrangement, as you can see, in order to achieve show that line. A lot of work for that initial mark. In the next part, you're looking at a discriminant which is greater than 0, 2 distinct points. Again, identify clearly what b is and multiply it out. Then you can see how much easier that is to do. Working out until you get the final answer. Solving in the last part, factorising, bit of an easier one to factorise. Again, clearly show the method, sketch, shade the sketch, then write down your final inequality symbols. One is part of question 2 for June 12. You had a coordinate on an equation of a line. To find the k value, put the coordinate in place of x and y. And you can see you get an equation which solves to work out k. This type of differentiation question is worth practicing. It hasn't come up for a while, so it may well come up in this year's exam. First part, pay attention to whether the surface area includes the top or not. It does in this case. So let's have a look at the solution. First part, as you can see, is working out the surface area, work out an expression. We know it equals a particular number, and then dividing that equation by 2 leads to their answer. To work out the volume equation, start with the volume of a box. The 3 sides multiply together. They've eliminated y by making use of this equation by first rearranging it. So over here you can see the rearrangement of the equation from A to get a replacement, a substitution for y, which goes here. And then they've simplified this. A good way of simplifying it is to multiply out the top line first, and then both of those answers on the top are individually divided by 4x, leading to a final simplified answer. Don't spend too long on this. It's quite difficult to achieve, and you can still do the rest of the question having not succeeded. Be careful with the differentiation. You needed to understand how to differentiate that fraction. That's something which you might want to have a look at to see if you obtain this answer. That's critical for success in the rest of the question, and have a look at the rest of that solution as well. Paying attention to the fact at the bottom, when you're working out the second derivative, look at the way they've presented the information about it being a minimum point. The initial difficulty in this question is clearly being able to identify this radius of this circle. So, because the centre is 5, 8 and you've gone 5 across and 8 up, it's that distance which is the radius, which was the x value. So it's 5, which is the radius, and they want it written like this. So have a look at the solution, and you can see here, instead of 5 squared, I've written 25. If they'd written a k squared there, I would have written 5 squared instead. Verify this point lies on the circle, put it into the equation of the circle and demonstrate that it works. And then write down also a clear statement at the end. Equation of the tangent is a fairly standard one. You work out the gradient between the centre and the point C first, and the tangent is going to be perpendicular to that radius. And then you're using the line equation. Rearrangement, easiest way, multiply this by the bottom of that fraction, as you can see. Length of CM is done quite simply, and if you're interested in this last part, have a look at drawing a sketch for the diagram. So you're drawing a circle with a chord, join the centre of the circle to the middle of the chord, and join up a triangle by joining a radius. A difficult question to end with. The first part, you need to understand what we mean by increasing. An increasing part of the graph is when the gradient is positive. So the starting point for this question will be the gradient is positive, which will lead to this statement. And what they've done there is they've rearranged that statement. So they've divided by 2 and they've taken things to the other side, or you can think of it as dividing by -2 to lead to this answer. The next part of the question, just solving it, is a fairly standard question. Just have a look at the answer. To demonstrate that at x equals 2 the tangent is parallel to the x-axis, have a look at what they've done. The gradient is 0, and if it's 0, it's a flat horizontal line, which means it's parallel to the x-axis. In the final part of this question, quite a lot of work involved, as you can see. What we'll need to do is work out the equation of the normal at Q, and you can see the method they've employed to do that. First working out the gradient of the tangent at Q, and then the normal is perpendicular to that. There's the equation of the normal simplified. The equation of the tangent at P was y equals 3. If you're not sure where that comes from, use the line equation like this with the correct coordinate and a gradient of 0, and you will get this equation. Then to find the point of intersection, we're solving this with this line, the intersection of these two lines. Easiest way to do it, substitute that y with 3, which is what they've done here, as you can see, leading to a final answer with the correct r value written as a coordinate. Have a look at the next question. This is about translation. So if we're going to translate it vertically by -3, the letter x in the equation is replaced with a bracket x plus 3. And you can see that's been carefully done. And the vertical translation appears as a number at the end of the equation. The only thing you would be expected to do with this is still say don't simplify, but we would probably expect you to combine those two numbers to make -10. Again, an awkward surds question just for you to check by yourselves to make sure you've got the right answer. This is a kind of question that doesn't come up often, but if you're familiar with it, it's quite easy. In the first part, you're told if you divide p of x by x plus 2, the remainder will be -150. Just think how you would use the remainder theorem. You put -2 into p, and we know the answer should be -150. So as you put -2 into your p equation, we know it equals -150. This is then simplified, as you can see, to lead to the given answer. Part B is very similar. You're going to this time be told that there's a factor, x minus 3. So we know if we put 3 into it, it should equal 0. So again, demonstrate putting 3 into the px equation, and we know the answer equals 0, which results in a similar type of equation. In the final part, to work out the value of c and d, the two equations you've obtained from part A and part B are solved simultaneously. You might want to check these numbers actually work. A question which you'll have to think about. In the first part, you're given a rectangle and the length is x and x plus 4. The perimeter needs to be greater than 30, so here you can see you've worked out the perimeter of that rectangle. A sketch may help, which simplifies to this, and we know that's got to be greater than 30. And if you simplify that further, you'll see it simplifies to there, show that answer. The area is less than 96, so again, they've started with a sensible statement, area of a rectangle, length times width, less than 96. As that simplifies, you get a quadratic inequality. In part C, you solve that quadratic inequality. For part D, you've got to combine the answers that you obtained in part A, which were these, and the answers you obtained in part C. So for the area condition, x has to be less than 8, bigger than -12, and for the perimeter condition, it has to be bigger than 5.5. If you solve this further, x is bigger than 5.5. So x has to actually be in between 5.5 and 8. Greater than 5.5, but less than 8. A fairly straightforward question. Have a look at the midpoint part, which is the only difficult part really in this question. The first part, you're working out the gradient of AB by rearranging the line equation. Make sure you do write down clearly what the gradient is. Then you're finding the equation of a line parallel to AB, written in a particular form. And in the next part of the question, you have to identify the end coordinate. Some of you may need to rearrange equations to do this, but either way, check your answer. And the last part of the question involves solving simultaneous equations. Again, worth checking your answer at the end to make sure you've got the right answer. A fairly straightforward question if you understand all the definitions and don't make a mistake initially with differentiation. So, for working out dv by dx, it's really about being careful with this. That becomes 3t squared divided by 4. the way to think about this is 3/4 times t squared. Rates of change are to do with the first derivative, so in b part 1, all you need to do is put t equals 1 into dv by dt to get an answer. The next part, because the gradient at this position t equals 1 is negative, that means it's a decreasing function. That means it's going downwards. Graphs which are going downwards will have a negative gradient. Graphs which are going upwards will have a positive gradient. And the last part of the question is fairly standard, working out a second derivative and showing whether something is a maximum or minimum point. Fairly straightforward question until the last part. So just have a check of your answers in the first part with the remainder and working out the quadratic and demonstrating, that x plus 1 is a factor and working out the quadratic factor over here. Okay, the last part of the question is going to ask you to show there's one real root. That means exploring, for instance, what happens with this quadratic factor. So you need to explore this quadratic factor. So here, discriminant applied to this quadratic factor gives you a negative discriminant, which means that this quadratic factor is going to result in no real solutions for this cubic graph. The only solution will be from the single linear bracket, which is x equals -1. A fairly straightforward question, just remind yourselves how to do this. In the first part, make sure you do realise it's a linear inequality, so you're involving multiplying it out, rearranging, etc. Be careful with this part. This bracket is multiplied by the -4 before, not combined with the 5 first, and then follow the lines of working out. In the second part of the question, in order to solve it, you need to take the 12 to the left hand side. You can only solve a quadratic inequality if you've got 0 on one side, and that was the key step. The rest of the question is relatively straightforward. Fairly straightforward question with some technically difficult things. Again, have a look at the solution. First part should be relatively straightforward. Be careful, they want k there, so they don't want 10 squared written there, they wanted 100. Working out where it crosses the x-axis, you're putting y equals 0 into the graph equation, leading to 2 answers. Working out the equation of a tangent, not too difficult. Have a look at it a bit more carefully. You can see, since the tangent has a gradient of 5/2, you're working out the equation of the normal. So the normal will have a gradient of -2/5. And again, that needs simplifying. Once you've put it into here, multiply this side with 5, keep the -2 on this on the right hand side, multiply and simplify. Last part of the question, as you can see, involves finding the intersection between a line and a circle. How do we do that? You don't need to multiply it all out, just have a look at how I've done it. Just be careful, you're replacing the letter y in the equation with 2x plus 1, and that will result in that bracket simplifying to 2x plus 1 plus 8, which becomes 2x plus 9, which is how you want to simplify it before you expand this bracket. So to solve this now, we're expanding both brackets, taking everything to one side, making a quadratic. This quadratic simplifies nicely by dividing by 5. And in the last part of the question, you're going to be asked to solve that quadratic. So the last part of the question will involve solving this quadratic here. And the clues in the answer, they're basically telling you that to solve this quadratic, you're going to have to use the quadratic formula. And the quadratic formula should simplify into that form. So have a go at doing that.